You started?
Yep.
All right, so this is chapter 4, and this is on applications of derivatives. Now, this is all applying how we had the derivatives last chapter to situations with curves. Basically, the part about the derivative, we assume you know what you're doing. So today we need to talk about some different types of vocabulary. So the first one is extremas. The word extremas means that we're looking either for a maximum or a minimum point. Now, when we have this, so like if I gave you a curve, this point would be an extrema. It's a maximum point. Well, if I had a curve that went like this point would also be extrema and also that point. So a curve can have more than one extrema. Now, we think of it as an absolute if it's clear at the bottom. Now, if you notice here, these two tails go forever, so there would be no absolute minimum. This would be basically called a local. And then of these two, we have, these are both maximums. This would be the absolute maximum because that is the tallest y value we can have. So that's basically what this is saying. And then we'll talk about the extreme value theorem. We first deal with a function in a closed bracket. In other words, between a and b, including those endpoints. Inside that brackets, we have some f of x that's between the absolute minimum and the absolute maximum. All right, so for right now, I want you to copy this much down, and we should have enough time to wait. We shouldn't have to break it. You guys will write fast. Or do you want to write it at the end?
We can do that.
How about if we write it at the end? All right, if you're with me in the book, on page 222, and if you look at the red curve, which is a cosine curve, you can see the maximum at 0, 1, and there'd be two endpoints of the red curve. There'd be two endpoints and two minimums because they have the lowest y values. And then if you look at the sine curve, you can see the maximum and minimums. Now, some curves have no maximums, some curves have no minimums. If you look over on the next page, figure 4.2, if you look at the first one, this is the graph of y equals x squared. It has a minimum, but no maximums. But then if I take the same curve and then I restrict the domain between 0 and 2, I now have both a minimum and a maximum. And if you look at the third one, notice there's an open circle where the minimum should have been, so there's no minimum, only a maximum. And then if you look at part D, we have open circles at both the endpoints, so there'd be no minimum or maximum. Then we talk about the extreme value theorem that will be used. And basically, if you look at the pictures on page 224, so you have a curve between a big M and a little m. Basically, that's what they have. And you have a continuous function between those two values. And if you look at all four of those examples, it is continuous. And that is important to us, that it will be continuous. All right, now that's where we bring in, here we've talked about absolutes. Now we're going to talk about what's called a local extremas. Local extremas are highs and lows, but not the overall high or the overall low. And you basically find them by setting the derivative equal to 0 and solving. So once we know what the function is, so like if we had y equals x squared, you would take the derivative of this, and you'd get 2x. You'd set your derivative equal to 0, and you are going to have an extrema at x equals 0. So basically, you take your function, you take the derivative of it, set it equal to 0, and solve. You could have one point, you could have multiple points. But C will be the location of a local extrema. Now, they're also going to use the word critical point. That's another vocabulary word. Critical point is a point where the derivative is equal to 0 or where the derivative is undefined. Okay, so those are other terms that you need to have. So if you're in the book on page 225 and you look at that top picture, can you see the difference between absolute minimums and local minimums?